Good morning, everyone. My name is Andrew Lawson. I'm the Analytics Manager at RavenPack in Spain. And the analytics team at RavenPack is 90% a Lisp team. We've presented at these conferences before. I believe this talk will be going out just before lunch, so I'm going to keep this short and hopefully reasonably entertaining. It's mostly Lisp related, but it's more a talk about recent experience than anything else. Nothing theoretical, no new libraries or anything like that. So RavenPack is a company that processes data. We process news stories and other incoming information into a structured format that our clients find useful. And our clients are mostly banks, hedge funds, financial institutions of various sorts, insurance companies, that sort of thing. The majority of that data processing is done in Common Lisp, although there are other languages used within the company. The actual majority of the work done is in various Common Lisp applications, and also our editors and the maintainers of our metadata also use internal Common Lisp based applications. What I'd like to talk about today really has been our experience over the last 2 months as the COVID-19 crisis has required that, as with many companies, all of us leave the office and work from home. In our case, our entire team, minus 3 people currently, work from the Marbella office, and it's always been our preference. I think I'm in agreement with all of my management colleagues at RavenPack that we prefer to have people for face-to-face meetings, and it's just much easier to communicate, discuss, and generally complete work when everyone is more or less sat around the same table. Now, we've had to compromise on that a little bit to get the right people. We have to be flexible, but we're still in a situation where in hiring, we prefer if people can come and work in Marbella. And I think that preference will probably continue, despite what I'm going to talk about today. Our Lisp developers tend to work on multiple different projects, which may be applications, customer-facing applications, or internal applications. For example, the maintenance of our metadata is done via a Lisp application. This, unfortunately, from the point of view of remote work, means that they're dealing with multiple project managers, multiple developers, and possibly, in the case of internal applications, multiple users. Which means multiple meetings, although not every day. But it does mean that they have to have open lines of communication with several different people. And of course, remote work makes that a little more inconvenient, depends on your point of view. In my case, I very much am a fan of managing by walking around. I like to get up and just go and talk to people, be it my own team, or if I'm sorting a problem, just walk across the office to deal with the right person. And that face-to-face component for me has always been very important. In our case, it happens that leaving your seat and heading anywhere in the office takes you directly towards the kitchen and the coffee machine, or in my case tea, so it's always a good excuse for refreshment. One convenience also is that between us and the coffee machine is almost all of our internal users. And so bug reports, improvements, etc. can be very quickly be discussed just within a short walk. For this reason, we've always thought remote work is fairly inconvenient, although of course not impossible. As we do have some remote members of the team and other parts of the company, we did before the COVID crisis, have a sort of remote infrastructure in place, although only being used by a small number of people, or by myself or some other people of the team, if we have to do any work out of hours, weekends or whatever during emergencies. So this means that we already had a VPN in place, and a little script called sshuttle, which basically uses SSH to provide a pseudo VPN. Some people prefer one, some people prefer the other, and both give full access to our internal networks. Our internal web apps also have external endpoints, things like Jira, GitLab, and also our internal applications, which we may need to refer to, again out of hours, also have external endpoints. Much of our infrastructure these days is also in AWS, so there's no issue there. No matter where the developer is, almost anything is a simple connection to the VPN away. Also, most being Lisp developers, using mostly Emacs and the console, almost anything can be accessed via SSH. There's no need for any graphical interfaces to almost anything. So it does seem that we would be reasonably well prepared for a sudden everybody remote event, except for a simple lack of practice supporting 100 and something people rather than the 10 or 15 that might be using such infrastructure a few months ago. Of course, the challenges are and were greater than that, as there are many parts of the system that that were thought about mainly as being accessed from within the office, from a very, very fast network locally, rather than across the country, or in some cases across the Atlantic. Now, we were lucky that several of the things I'm about to talk about were effectively already in place or under development when the COVID crisis came on the horizon. So we thankfully haven't really had to do any panic implementation. But what I'm going to talk about here are some solutions to the problems I've talked about that have turned out to be rather useful or work very well. And none of these will be a surprise to anyone who's used Lisp for a long time. But there's some parts of the Lisp world that we haven't really delved into much before now, but which have turned out to be very useful. So firstly, several of our applications require large amounts of data in memory. A couple of them require about 2 gigs, and there's one application that can hit 10 or more gigs while running, our internal editors application, because it requires many versions of our code and data to be available to the interface at once. Now, startup of those applications in the office, where our DevDBs are already running, can take 20-30 minutes, maybe a little longer depending on the day. But that's not excessive if you're doing it once a day, if you can go and have a meeting, if you can go and have a coffee or whatever. You know, we can live with it, and we always have. It's reasonable. Most of that time is actually not code, it's simply loading data from databases. It's the query time and the data transfer time between 2 machines that are 10 meters apart on the same network. Now, the problem, of course, with that is if you're trying to run stuff at home locally, you're going via VPN, so your own local network connection, and who knows where your packets are going before arriving to the office. Now, our office network is actually reasonable, but there's a lot in between. But things do slow down significantly, so what previously was 20 or 30 minutes can take well over an hour or longer in bad network weather. It turns out that about 1 or 2 years ago, I did a little experiment where our normal macros that we use to connect to Oracle databases, I introduced some arguments that would basically cache the data coming in locally and allow the macro to return that cached data rather than the database query. This was an experiment at the time, and it didn't show any particular speed up over our local connection, and I left it there. A few months ago, one of our developers started to play with this, a developer that works remotely, precisely because it was taking a long time to load data. And it turns out that he, who was suffering from multi-hour loads, by making appropriate changes and some improvements, was able to get his loads down to as fast as an in-office startup, or faster, depending. And this has now become a very useful tool for a few people who require it. It depends on what we're working. But those local disk caches have been really useful. And of course, they have a side effect of allowing a repeatable load. Not all of our data is stored versioned. And so there's a certain risk that if you're trying to debug something, you don't have access to the exact data that was causing the problem, whereas someone who is caching loads may, either through plan or accident, have access to that data. So that's a path we're going down, and I think we have to develop more fully. But the idea of versioning and caching data locally from the database is certainly useful under slow network conditions. Another part of this caching strategy is stories. As I said, our input data is news stories and other things from various providers. We'll call them stories in general. And they're usually stored either in a local database or more commonly in Amazon AWS S3, which for those that don't know is basically a huge distributed hash table in the cloud. It's pretty quick, but again, downloading very large numbers of stories from S3 over a possibly slow domestic line can be a bottleneck at runtime, particularly as we often run many hundreds or thousands of stories through a system to validate it. So people have started to cache those too. And again, bulk test runs, etc. are turning out much faster for those that would normally have networking problems, and certainly no slower for those of us who would normally have fast connections to S3. Of course, all of this does bring up the worry of what happens when your cache is outdated. In the case of stories, it's not such a problem. They don't tend to change. But all of our other metadata changes day to day, or at least during the week. And so we have to be very, very careful to invalidate the caches whenever any important changes happen, and certainly when we know that important changes have happened. There's a pattern here, basically, which is to make yourself independent of distant resources where possible, distant or unreliable resources, taking appropriate care. We have no functional need to pre-build images, or at least we didn't until perhaps more recently, where we're starting to look at things like spot instances and the like in AWS. But most of our applications are running as a single instance in any particular place. And so just starting them with a script from source has been the way to do it for many years. However, again, going back to startup time, in particular loading of data, this requires a full load. Maybe cached locally, but still a full load. We're still talking about tens of minutes for some applications. And home workers want fast restarts when something goes wrong, the image crashes, or they require an up-to-date image. That is up-to-date data, not yesterday's or the day before. So having access to images containing the latest code and data built that same morning and ready to start can make a huge difference. It requires a simple 2 or 4 gig download from S3 or something like that, which across modern connections, even at home, can be a matter of minutes. And then just being able to start and restart that image again and again during the day if necessary, after some damaging experiments, can be a huge help. So we're now building these images daily, sometimes more often, and storing them centrally so that everyone has the opportunity to access them. And in fact, we're thinking of starting to build images off of all of our development branches, some of them personal, some of them more commonly used by multiple people, to have this resource available for anyone any day. And of course, having repeatable builds, even if they're only supposed to be for development, does mean that testing becomes more simple. Testing scripts, tests built into the code, across the network testing, testing via databases and all that, as long as you have an image already prepared and ready to go, become much quicker and more easily to do. In particular, it's important to note that these images that we're creating here that are not necessarily for production use do not remove anything. So there's no tree shaking going on. They're also very large, and there's a lot of functionality still in there that we make use of. We're also using our pre-built images now for internal production applications because we can, and because we're planning to use pre-built images in production more often in the future. So a lot of testing is going on. One important thing is to make sure that all of the configuration options we'd normally have can be changed on a pre-built image after build and still have effect. It used to be that if you had saved an image and changed a config variable, it had no effect because it had already been read into some structure or some running code, some lambda or something like that. And so in recent times, we've made an effort that when you start an application, absolutely nothing has already been initialized where possible, meaning that a change in config immediately before the run, so after restarting the image but before running the application, has full effect. Effectively, all of our configs are now runtime configs rather than compile time config. This means that things like our database pools, which were used to build the images, have to be reset and emptied before the image is saved, so that on starting the application, they are lazily set to a new config, which may not be the same database as that from which they were originally built. There's also things like data loading abstraction, whereby we don't simply load data, rather we ask for data to be loaded, and the system ensures that if something was loaded 5 minutes ago in the database build, now on running the application after restarting the image, we don't reload exactly the same data. That would be a waste of time. So if something requests the same data twice within a certain time period, it is not reloaded, things like that. There's some abstractions built in there. Networking, etc. also has to be carefully reset. Connections need to be torn down and things like that. So anything to do with the build has to be reset, threads are killed, etc. before saving the image, and they will be restarted when the application or just development starts again. Other important thing is source file location, so that when you get your pre-built image, you attach to it and you just do a load system of sorts, it knows exactly where all of the Lisp files are, and it runs as if it was just a Lisp loaded from zero. We used to run everything from source under Emacs. We were developing under Emacs, and so the easiest way to start an application, be it development, staging or production, was simply to start Emacs and load a short script effectively that would run the Lisp under Emacs. It meant that if anything went wrong or there was any investigation needed, we already had a development system attached. And so it made sense that all of our auto restarting overnight of our dev applications, the loading of new data, etc., was done via Emacs Lisp scripts running in the Emacs. This, unfortunately, as you might expect, has grown into an overgrown library of very application-specific restart and reload instructions, and it's something we're trying to move away from. As we now have pre-built images in most of these cases, we just embed them in Docker containers and have a container management app to do our employment. Whether you believe Docker is a good or bad thing, and the jury is out for myself in my case, certainly from the point of view of just shipping stuff around and stopping it in a fairly standardized manner, it makes things pretty easy. And any of our Lisp images inside Docker containers already are set up so that you can just connect via Slime or Sly to set up standardized ports and things like that. So debugging these images is still just as easy as it would have been, especially since they also have access via mount points to all of the Lisp files that they would have previously as well. So we're ensuring that no matter what use these Docker images with the pre-built Lisp images are put to, they are just as debuggable and easy to interrogate as the previous application deployments. Moving away from Lisp for a second, I thought I'd just mention what else we'd been doing. We've been using Zoom most of the time. It's been the most reliable video chat app. We have tried others, and none of them have been as reliable or easy to use as Zoom. And people are starting to get creative with the green screen effects and things like that. So I think we're quite happy with our choice there, despite the obvious security concerns that have come up. We're also continuing code reviews and things like that, screen, tmux, if two people are pair programming or pair code reviewing. Teammates has been very good. Has been a very good way of broadcasting any sort of Emacs session or whatever during a code review. And for myself at least, video calling everyone rather than just the people that are remote has become a way of life. I used to be a little uncomfortable with video calling compared to just wandering over and talking to someone. But given that I'm having to do it with everyone, it's no longer much of an issue. So I'm actually quite happy with it now. I think I've got my system set up, microphones, earphones and that. Once you get yourself sorted, I don't think it's much of an issue. Within RavenPack as a company, we're all working as normal, just from home. The entire company, there's been no change there. But given the circumstances, given that we have all this data at our disposal, we ended up creating a little application. It's free. You can all go and have a look. This URL you see on the slide here. It's basically a coronavirus news tracking application based mostly on our own internal data and some stats we get from elsewhere. So admittedly, the dashboard itself is not written in Lisp. It's JavaScript and React apparently. And it's not doing any queries, rather the data is pre-prepared by the backend and just left in place to be downloaded. It's almost entirely RavenPack data with the addition of some stats, I believe, from some official websites. And the advantage of this is that for once I can actually show my mother or anyone else what I actually do for a living, because explaining news analytics to people, it's not fun and it takes a while. I encourage you to give feedback, by the way, if anyone likes it or doesn't like it. Do tell us what you think. So the point of this is that working remotely isn't so bad, although I would prefer to be in the office. Infrastructure has been reliable, and all of the things I've talked about here has basically meant that Lisp development has continued more or less as normal. And there's been a few things that have turned out to be improvements, all of the image building, etc. And we'll probably improve things once we get back to normal. I think you just have to ask my dogs if you want a second opinion about what being stuck in the house in front of a computer all day is like. It's not bad. Feels a bit lonely, but I think we're happy enough. This is the point where I always tell you, every time I've done one of these talks, that we're hiring. We're not hiring right now, as you can imagine, given the lockdown and given that we're all working at home. It's not a good time to bring someone on board. But as soon as things are back to normal, we expect to be hiring again. So anyone who has contacted us or who's thinking of contacting us, don't worry, be patient. Feel free to send in your CVs. We just won't be doing any interviews until the lockdown is gone and things are looking a bit more positive. Thanks for listening. I hope there's been some stuff of interest here. And please stay safe, everyone, and enjoy your lunch and the rest of the conference.